All right, greetings everybody, and welcome to what is probably going to be the first video on this channel. And this is actually going to be a runtime type token system. This is also my first C++ video, which I guess would make sense. But I'm super excited about that because I think out of all the languages, C++ is my absolute favorite. This channel will not be strictly about C++. I will probably be doing other languages as well. But I probably will be doing a lot of videos on C++ as long as everything gets according to plan. But for now, we're here to talk about type systems, and effectively, this video is going to be really short, really simple, but it's going to show you how to get runtime information on a type, and it's going to be very rudimentary information. Effectively, it's just going to be, hey, what type is this? And you're going to get a token back, and that token will be unique on every single type. Now, you may not be terribly thrilled about that, but this video and another video that I'm about to be doing are going to be build up for a third video. And in that third video, I'm going to put a lot of the pieces together, and hopefully you're going to see something or be able to create something that is going to be super helpful to you when you're programming in C++. And it can also be ported to other languages like C Sharp. I've actually written a similar system in C Sharp. So anyway, let's go ahead and get started. The solution that I'm currently doing, as you can tell, this is Visual Studio. FYI, this will be using C++ 11. Should be cross-compiler capable. I'm not going to be doing anything that is particular to Visual C++. So if you're on GCC or Clang, have fun. Sorry, G++. All right, so anyway, we're going to go ahead and get started. I've got my main right now, and that's all I've done. Just create a new project, console application. So that's pretty much it. I've added an include in a source folder. The only thing that I have done is in the includes directory, I've gone ahead and added my include, which is more visible here. So I've just added that, and that's just so that, come on, there we go. That's just so that I can just include things directly without having to use the folder name. So the first thing we're going to want to do, though, is we are going to want to create our type header. And I'm going to call this thing typer. And that's only because type is a pretty common word, and I don't want to inadvertently use something that will get reserved in a future version of C++. So, all right, so how this thing's going to work is we want to essentially just have some sort of function. I'm going to make it global. If you don't like globals, that's fine. I understand. Globals are typically frowned upon. This particular one, it just kind of makes sense as a global, so I'm going to go ahead and do that. Also, I'm not going to be using namespaces. That's bad practice. Put your stuff in a namespace if you plan on using this in production code, but I'm trying to keep it simple here, so I'm going to be namespace free. But anyways, yeah, so we're going to have a function, and all it's going to do is we are going to pass a type to it, and it's going to return back a number, a token, essentially. So we'll go ahead and do that first. And what we'll do, obviously, if we're going to be using types, then the first thing that probably comes to your mind is templating. And indeed, that's what we're going to do. So the first thing we'll do is we're going to create a template, type name T, and T, of course, will be our type. We're going to have an inline. All right, now ignore this for now, because I haven't defined this yet, but type ID is going to be our token. And we're just going to simply call this getType. All right, so that's our start. This is essentially going to be our function signature right here. We just call getType, we get a type ID back. Simple as that. Now, like I said, we don't really, we haven't defined type ID yet, so we need to do that somehow. And since we're going to go ahead and just use a number for it, the easiest way to do that is probably just to use something like using type ID. This is C++ 11 construct, by the way. It replaces type def. And you can do something like unsigned int. That's totally doable. I'm actually going to include std_lib, and I'm going to make type ID equal a std size t, because a size t is guaranteed to be able to address everything in your system RAM. And I want to make sure that, you know, it's highly unlikely you're going to have that many types in an application, but there you go. Better safe than sorry. So, all right, so we've got our type ID. So now at this point, we've almost got something that will compile. We aren't returning a type ID, so that's what we need to do next is we need to figure out how to uniquely get types back from this. And so the way we can do that is by creating a static field inside of our function. So we'll create a static. Now, again, I could just do a static, type ID like this. And we'll call it ID. And we're going to assign this to be 0 for now. This will work. But I was thinking, what if we're getting types inside of threads for whatever reason? Okay, I know, I'm getting a little crazy here, but let's make this thing bulletproof. So what we're actually going to do is we're going to put this thing in an atomic. And an atomic is just there's a lot behind an atomic in concept, but effectively this will make the type ID, or this particular field, thread safe. So if I call this function at the same time within two different threads, I'm not going to return back the exact same value for different types. That's the whole point of that. So, all right, the logic for this is pretty simple. So if ID equals 0, then what we're going to do is we are going to grab, come on, can't type today. We're going to grab the next type ID, and we're simply going to return it. Now, again, we haven't defined that, so we'll do that next. But effectively, yeah, that's what will happen is the first time this is run for a particular type, this value will be 0. We then check for that and then assign the ID to be the next ID in the list. And this is going to give us that ID and increment a counter. That's all it's going to do. And then we just return the ID. So now subsequent calls for that exact type will go, oh, our ID is no longer 0. So it's just going to return that ID. So it's pretty simple. Essentially, it's just if it doesn't have an ID, i.e. the ID is 0, then it creates one and saves it, and then it returns it. And if it does have an ID, it just simply returns it. So this is pretty quick. Not a half bad way of doing things. So the next thing we need to do is we need to define the next type ID. And to do that, we're going to go into our sources over here. And we're going to add a new item. And we'll call it typer.c++. And we're going to go ahead and include typer.h. And once again, basically, we need to define our current type ID, whatever that happens to be. So initially, that's going to be 0, but we're doing this in a separate C file to make sure that whenever we ask for, or C++ file, because wherever we ask for a type ID, no matter where we are, we want to make sure that we're using the exact same counter all the way through. So we're going to call this current type ID. We're going to set it to 0. And now we're going to create a new function, which will return type ID, and this will be next type ID. And this is the simplest function on the planet. It's just going to increment type ID and return the value. And that's pretty much it. So if we compile this thing, I just hit Control-Shift-B to do that. That's the quick way to do it. We'll see everything works, but of course we haven't really done anything. So let's go ahead and include typer.h. I'm going to go ahead and make sure that compiles real quick. Yep, header files are being found, so that's good. All right, so now what we can do is we could do something like std cout type of integer is, and then we can do, so we just basically call getType, and we want int. All right, let's do one for a long. We'll do one for a short even. No, let's do one for a char, or a char, however you want to pronounce that. And then finally, to make sure everything is working as expected, we'll repeat the integer call. So whatever this, we'll get to that in a second. Whatever this returns, we should also get here as well. So, wow, simplest program ever, and I've already made a mistake. That's very impressive. Of course. Wait a second. Because I think I'm missing, yes, I am. Okay, missing a prototype. So type ID equals next type ID. There we go. Now that should build. Really? Man, this thing's having it out for me. Oh, why did I put an equal sign there? We'll never know. Okay. There we go. All right, so if we go ahead and run this, we'll see type of integer is 1, type of long is 2, type of car is 3, and type of integer is 1 again, which means it did indeed remember its type, and will always return that no matter what. So that's basically it. You're probably wondering, why on earth would I want something like this? But effectively, the most important reason that something like this would come up is if you are categorizing things inside of lists and you want to categorize them by their type. This gives you the ability to do that. And that is going to come in very handy very soon. So I hope you guys enjoyed the videos. If you have any questions, if I went too fast, whatever, just let me know in the comments below. This is my first video, so I'm probably kind of getting into the swing of things. I have another YouTube channel, but I do completely different videos on that. So this is my first time doing videos that are programming oriented. So anyway, yeah, if you have any questions, comments, whatever, just throw them down below in the comment section, and I will try to respond to you guys as soon as I can. Thank you guys for watching, and stay tuned for the next one, because I'm going to introduce a little something called capabilities. My own word for it, but they're pretty cool. So until next time, I will see you then.